Hello, this is Mr. Waters, and here is another helpful homework video. And this is going to be related to our new chapter, which is about sequences and series. And specifically, I'm going to be beginning here with page 789, which is about some general questions about sequences. Okay, so first off, what is a sequence? One way of looking at a sequence, and it's kind of a simple way to look at it, is that it's really just a list of numbers that follow a pattern. So like 1, 3, 5, 7, ... That's a sequence. And you can see that once we discern what the pattern is, we could probably go ahead and predict some further members in the sequence, and we can list as many as we want. Okay, so sequences, and here's another one. So we could have one like this. So let's say 2, 6, 18, 54, ... There's another one with another pattern. Or we could have a sequence that looks like this. 1, 4, 9, 16, ... And we separate the terms in the sequence with a comma, and then the 3 dots indicate that the sequence just keeps going. Now, sequences can be finite. That means that they have a certain specific number of terms, although it might be a large number of terms. So a finite sequence would be like this: 1, 3, 5, 7. That has a specific number of terms, which is 4. Okay, so, or it could be an infinite sequence, like the ones I wrote over here, and the ... indicates that it just keeps going on forever, so those would be called an infinite sequence. The terms in a sequence are numbered according to their position in the sequence. So for example, in the sequence I wrote out here, this one like that, 1 is the first term, so we would say first there. 3 is the second term. 5 is the third term, 7 is the fourth term, and so on. And we would usually give a variable, often it's n, to indicate how many terms there are in the sequence, and also to indicate which number or which position in the sequence the term has. So since this sequence has 4 terms, we would say that n is equal to 4. And we can name the whole sequence with a letter or a variable or a name, something like a sub n. A sub n, or t sub n, or g sub n. Something like that, some name to kind of indicate all at once all the terms in a sequence. And then once we have that, we can remember that n refers to a position number. So for example, within the sequence, so for instance in the sequence we just did, a sub 1 is equal to 1, a sub 2 is equal to, that's supposed to be an a sub 2 is equal to 3, a sub 3 is equal to 5, a sub 4 is equal to 7, and so on, where the n number, this n number here, indicates the specific position that a given term is in the series. So if I say, if I ask you, tell me what a sub 7 is, that would be asking, in maybe this sequence that we're talking about right here, what would be the 7th term. Okay? Anyway, so it's quite convenient. And that's just, we want to get used to the kind of terminology here. Now the little number on the bottom is a label. It's not an exponent. That's called a subscript, and that's just a kind of label. It's not any kind of an exponent or a multiplication thing. Okay? All right, so if we want, one way to indicate a sequence is simply to write out the list of the numbers. So let's look at the second sequence I wrote out there. 2, 6, 18, 54. I might ask, what's the next term in the sequence? So in order to answer that, you would have to look to see, well, what's the pattern that generates, that relates each of the numbers in a sequence? Well, you can see here that each time I'm multiplying by 3. So it's reasonable to assume that in order to generate the next term in the sequence, we'd multiply by 3 again. So we multiply by 3. 3 times 54 is equal to 162. So the next term in our sequence would be, we'd write comma, 162. So if we wanted to generate, and this will be one of your homework questions, if we want to generate the next 5 terms in a sequence, I would just keep multiplying by 3. I would multiply by 3 again. So I would do 3 times 162, and that's 3 times 2 is 6, 3 times 6 is 18, 3 times 1 is 3, plus 1 is 4. So the next term would be 486. So you can see here that now I've generated the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. So we would say a sub 5 is equal to 162, and a sub 6 is equal to 486. I just want you to make sure you're getting used to that terminology. Now notice that in writing out our sequence here, notice that we made, in effect, a t-table. Just like this. It's a sideways t-table maybe, but it's a t-table. Where on top, or rather on the bottom here, I wrote down the terms of the sequence, a sub n. And on top, we have the terms in this, or the term number of the sequence, n. So this tells us, since we've worked with t-tables before, this tells us, or this brings us to the definition for sequences, sort of the official definition that the book gives us. And that is that a sequence is a function. Okay, so this is a sequence is. And this is the official book definition. A function whose domain is the positive integers. Pretty simple, okay? But remember what we mean by positive integers are the numbers 1, 2, 3, 4, 5, 6. So theoretically, the idea is that your input will be a term number, a position in the sequence. You know, the third term, the fifth term, the ninth term, whatever. Okay, the corresponding range value will be the actual member of the sequence, whatever. So like 486 is the range value because it is the sixth term in this sequence. Okay? All right, so that's one way to write out a sequence, is simply to make a t-table, just like one way to indicate any kind of a function is simply to make a t-table for it. So, but of course we know that another way to indicate a sequence is with, or indicate a function and therefore also a sequence, is with a formula. So see, all sequences, including the one that we just did, have got a formula. Okay, so for instance, the formula that relates the sequence that we just did is this. A sub n is equal to 2 times 3 to the n minus 1. Okay, so that's a formula where, remember that since we're going to generate a sequence, the domain, which is going to be n, is going to be the so-called positive integers, all the counting numbers, in other words, 1, 2, 3, 4, 5, and so on, okay, all the way up as far as we want to go in our sequence. Now, sometimes the sequences will start with 0 rather than starting with 1, but typically we'll start with 1 because we'll be talking about the first term or the second term. Okay, so if we're given the formula, we can use that to generate the terms in a sequence. So your very first homework question will be, they're going to give you a formula, and the question will be, tell the first 5 terms in a sequence. Well, here's what we would do. So we're given, let's say we're given that formula there. I'm just going to make a kind of t-table. I'm going to make a vertical one here because we're used to that shape, like that. Okay, we want the first 5 terms, so this is going to be n, and this is going to be a sub n. So this will be the first term. So this will be a sub 1, which is equal to 2 times 3 to the 1 minus 1. I just put the, like as usual functions, I just put the domain number in for the n. Okay, and that's 1 minus 1 is 0, 3 to the 0 power is 1, 2 times 1 is 2, so as we had up above, the first term is 2. Then we put in n is 2, that's the second term, a sub 2 is 2 times 3 to the 2 minus 1, that's 3 to the first power times 2 is 6. Third term, and you can see that if we just keep going here, and I'll just keep going on this, because you're going to have to do this on your homework. We put 3 in for n. That's 2. Okay, so 2 to the third, 3 minus 1 is 2. 3 to the second power is 9. 2 times 9 is 18. And you can see what our formula does in effect, and that's what the 3 is here for, is it multiplies each term by 3 to get the next term. Okay, so here is 4. And so a sub 4, this is 2 times 3 to the 4 minus 1, which is 3 to the third power is 27 times 2 is 54. And here's number 5. There should be a 4 there. A sub 5 is 2 to the third times 5 minus 1, which is 3 to the fourth power, which is 81, times 2, which is 162. Anyway, so you can see here that our formula generated the first 4, generates the term in a sequence, and you can generate this way any number of terms in a sequence. Okay, and so that's going to be your first homework question. That's how you're going to do your first homework question here. And you can see, by the way, that the formula is rather more convenient. I could also ask you, what is a to the 7th power? What's the 7th term in a sequence? And rather than having to multiply all the way up to the 7th term, multiply by 3 over and over again, I would do what's a sub 7, and put 7 into the formula for n. 2 times 3 to the 7 minus 1. That's 2 times 3 to the 6th power. And consulting my calculator here, 3 to the 6th power is 729 times 2 is, so that's 2 times 729 times 2 is 1458. And so a sub 7 in this particular sequence is 1458. Okay, so let's try another example here. Here's one. Let's say, so we're finding the first, what we're doing here is we're finding the first 5 terms in the sequence, and that's really not very good handwriting, huh? Okay, the first 5 terms in the sequence. Okay, so, and we're going to be given a formula for these, so let's say that a sub, now let's use a different designation so you get used to the idea that it can be anything. So let's say t sub n is equal to 3n plus 1, just to pick one. Okay, so we're going to we want to find the first 5 terms. So that means we want to know a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So I'm going to make an organized little table here, right, just like we did up above. See? Let me get back down to here. Okay. Okay, so n1, so that would be, and here is t sub n, so t sub 1 is equal to 3 times 1 plus 1, oh, that's 4. 2, t sub 2 is 3 times 2 plus 1, oh, that's 7. This is 3, t sub 3 is equal to 3 times 3 plus 1, that's 10. You can already see that this time what this formula does is, starting at 4 as the first term in the sequence, just adds 3 every time. So t sub 4 is equal to 3 times 4 plus 1, that's 13, not surprisingly. And this is 5, and I'll bet it's going to come out to be 16. 3 times 5 plus 1, yep. Okay, so anyway, so that's one thing we're going to need to be able to do. Now, another thing that they ask about is they give you a formula, they give you the formula for the sequence, but in a slightly different form. They call it the recursive form, or the recursive formula. And what recursive means is that rather than being given a formula that will generate just any term in the sequence like the one we just did, it gives a little rule that tells you what each subsequent or each new term in the sequence is based on what the previous one was. So it'll look something like this. They'll tell you, let's say t sub 1 is equal to -2, just to start there. And then they'll give you a formula. The next formula will look something like this. It'll say t sub n is equal to three times t sub n minus 1. Okay, now what that means is, now let's think about what that means. If n is any given term in the sequence, say t sub 3, or indicates any term in the sequence, t sub 3, t sub 5, t sub 7, you can see that n minus 1 would mean the term just before it. So if in this particular sequence there, or in this particular expression here, if t sub 2 would be equal, or t sub 2 would be equal to 3 times t sub 1, because 2 minus 1 is 1. Or t sub 3 would be equal to 3 times t sub 2. Or t sub 21 would be equal to 3 times t sub 20. So what the recursive formula does is it doesn't give you a general thing that allows you to generate any sequence in the formula. It just tells you how to get a new term in the sequence based on just the one before it. Okay, so here's how. So let's say you had to figure out the first 5 terms given the recursive sequence, or given the recursive formula. Well, that's going to look something like this. We'll just start with what the first term is, which in this case is -2. Okay, so here's n, and this is going to be, and so t sub 1 is going to be given as -2, right? So the second term, as I've indicated here, t sub 2 would be equal to 3 times t sub 1, which is -2. So t sub 2 is -6. Now that we know that t sub 2 is -6, we can say, oh, in order to get to t sub 3, I've got to multiply 3 times -6, because t sub up here, the t sub n is 3 times t sub n minus 1. So 3 t sub 3 would be 3 times t sub 2. So that, of course, is negative 18. Okay, so up here, let's kind of catch up. On the table here, we figured out that the second term was negative 6, and that the third term is now negative 18. So using our recursive idea, t sub 4 is equal to 3 times the t sub 3. 3 times negative 18 is negative 54. So t sub 4 is negative 54, right? And then now that we know that t sub 4 is negative 54, t sub 5 would have to be 3 times negative 54, which is negative 162. So t sub 5 is negative 162. Now here's how we'll write the sequence out. Now that we figured out what the sequence is, it's going to be negative 2, negative 6, negative 18, negative 54, negative 162, and so on, since they wanted the first. And I'm going to put dot, 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 because they said give us the first 5 terms, and so we're going to figure out the first 5 terms. But it could keep going. Now, by the way, back up here, we should have written this out as 4, 7, 10, 13, 16, dot, 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 to indicate that that keeps going. Anyway, so I think this will get you started on page 789. We've got some other things to deal with, but that'll be in the second part, part B of our video for this page. Anyway, thanks for listening.